Hello everyone and welcome back to Clear Creek Solutions instructional videos. Today we're launching into a new series involving the Western Washington Stormwater Management Manual. Today we're going over the Western Washington Construction Stormwater Pollution Prevention portion of the manual. You'll remember we did a series going over all 9 minimum requirements in depth. We did some modeling in that one. Now we're going to go into the Construction Stormwater Pollution Prevention guidelines that were given. I would highly suggest you look at the manual first, read that, or follow along as a supplemental tool to this, as this does not cover everything. This presentation is edited, not the end-all be-all. For, of course, all your decisions, you're going to want to go to the manual, but this might give you a good overview of what's included. Clear Creek Solutions provides a complete range of hydrologic and stormwater modeling and consulting services. So not only have we designed the wwhm 2012, we also do plenty of consulting in designing facilities in Western Washington and across the entire West Coast. And we teach wwhm-swmm and HSPF workshops involving those softwares and teaching people how to use them and the principles behind them with our 40 plus years of experience. So let's get into the summary of Volume 2. So Volume 2 addresses the planning, design, and implementation of BMPs before and during construction projects. In this volume, you will find 2.1, the soil erosion and sedimentation from construction sites details the impacts that can occur from soil erosion and sedimentation at construction sites if no construction stormwater BMPs are implemented. Now 2.2, construction stormwater pollution prevention plans or construction SWPPPs outlines what a construction SWPPP is, who is responsible for it, and the steps necessary to prepare and maintain it. Then we have 2.3. Construction stormwater BMPs contains a library of construction stormwater BMPs, which we'll go into, including both construction source control BMPs and construction runoff BMPs. Appendix 2A is recommended standard notes for construction SWPPP drawings, provides standard notes that may be used in construction SWPPP drawings. Refer to volumes 1, 3, and 4, and 5 for information on Volume 1, which introduces the measures necessary to control the quantity and quality of stormwater produced by new development and redevelopment. It includes an introduction to stormwater management, guidance on regulatory requirements for stormwater management, and details the minimum requirements for new development and redevelopment sites. Volume 3 provides guidance on how to choose, hydrologically model, and document stormwater BMPs in a stormwater site plan. Volume 4 contains a library of source control BMPs categorized by types of activities, and Volume 5 contains a library of design criteria for BMPs that project proponents can use to meet 1345, minimum requirement 5, on-site stormwater management, or 1346, minimum requirement 6, runoff treatment, and or 1347, minimum requirement 7, flow control. So let's get into soil erosion. What is soil erosion? Soil erosion is defined as the removal of soil from its original location by the action of water, ice, gravity, or wind. In construction activities, soil erosion is largely caused by the force of falling and flowing water. Erosion by water includes the following processes: raindrop erosion, which is direct impact of falling drops of rain on soil, which dislodges soil particles; sheet erosion, the removal of a layer of exposed soil by the action of raindrops, splash, and runoff as water moves in broad sheets over the land; rill and gully erosion, as runoff concentrates in rivulets, it cuts grooves, called rills, into the soil surface. If the flow of water is sufficient, rills may develop into larger gullies. Stream and channel erosion, increased volume and velocity of runoff in an unprotected confined channel may cause stream meander instability and scoring of significant portions of the stream or channel banks and bottom. The soil erosion by wind creates a water quality problem when dust is blown into the water. Dust control on paved streets using washdown water is not conducted properly can also create water quality problems. So there's quite a few factors influencing the erosion potential of a site. The erosion potential of soils can be readily determined using various models such as the Flaxman method or the revised universal soil loss equation. The soil erosion potential of an area, including a construction site, is determined by 4 interrelated factors: soil characteristics, vegetative cover, topography, and climate. We need to collect, analyze, and use detailed information specific to the construction site for each of these 4 factors when selecting construction stormwater BMPs to prevent erosion. The first 3 factors, soil characteristics, vegetative cover, and topography, are constant with respect to time until altered by construction. The designer, the project proponent, and the construction contractor should have a working knowledge of and control over these factors to provide high quality stormwater results. And then the fourth factor, which is climate, is predictably by season, historical record, and probability of occurrence. While predicting a specific rainfall event is not possible, plan appropriate seasonal construction activity and use properly designed BMPs to minimize or avoid any of the impacts of construction stormwater runoff. Then we'll go into how soil characteristics affect erosion potential. The vulnerability of soil to erode is determined by the following soil characteristics: particle size. Soils that contain high proportions of silt and very fine sand are the most erodible and are easily detached and carried away. The erosion potential of soil decreases as the percentage of clay or organic matter increases. Clay acts as a binder and tends to limit erosion potential. Most soils with high clay content are relatively resistant to detachment by rainfall and runoff. Once eroded, however, clays are easily suspended and settle out very slowly. Then there's organic content. Organic matter creates a favorable soil structure, improving its stability and permeability. This increases infiltration capacity, delays the start of erosion, and reduces the amount of runoff. The addition of organic matter increases infiltration rates and therefore reduces surface flow and erosion potential. Then the soil structure. Organic matter, particle size, and gradation affect soil structure, which is the arrangement, orientation, and organization of the particles. When the soil system is protected from compaction, the natural decomposition of plant debris on the surface maintains a healthy soil food web. The soil food web, in turn, maintains the porosity both on and below the surface. Then soil permeability. Soil permeability refers to the ease with which water passes through a given soil. Well-drained and well-graded gravel and gravel mixtures with little or no silt are the least erodible soils. Their high permeability and infiltration capacity helps prevent or delay runoff. So now we're going to go into vegetative cover. Vegetative cover plays an extremely important role in controlling erosion. It can do this by shielding the soil surface from the impact of falling rain, slowing the velocity of runoff, thereby permitting greater infiltration, maintaining the soil's capacity to absorb water through root zone uptake and evapotranspiration, and holding soil particles in place. So limiting the removal of existing vegetation and decreasing duration of soil exposure to rainfall events can reduce erosion. Give special consideration to preserving existing vegetation on areas with high potential for erosion, such as erodible soils, steep slopes, drainage ways, and the banks of streams. So now we're going to go into topography. So the size, shape, and slope of a construction site influence the amount and rate of stormwater runoff. Each site's unique dimensions and characteristics provide both opportunities for and limitations on the use of specific control measures to protect vulnerable areas from high runoff amounts and rates. Slope length, steepness, and surface texture are key elements in determining the volume and velocity of runoff. As slope length and/or steepness increase, the rate of runoff and the potential for erosion increases. Slope orientation is also a factor in determining erosion potential. For example, a slope that faces south and contains dry soils may provide such poor growing conditions that vegetation will be difficult to reestablish. Now let's talk about climate. Seasonal temperatures and the frequency, intensity, and duration of rainfall are fundamental in determining amounts of runoff. As the volume and the velocity of runoff increases, the likelihood of erosion increases. Where storms are frequent, intense, or long, erosion risks are high. Seasonal changes in temperature, as well as the variations in rainfall, help to define the period of the year for which there's high erosion risk. When precipitation falls as snow, erosion may not occur until the spring, when melting snow adds to the runoff, and erosion potential will be higher. Partially frozen ground reduces infiltration capacity. Rain on snow events are common in western Washington, between 1,500 and 3,000 foot elevation. Western Washington is characterized in fall, winter, and spring by storms that are mild and long-lasting. The fall and early winter events saturate the soil profile and fill stormwater detention ponds, increasing the amount of runoff leaving the construction site. Shorter-term, more intense storms occur in the summer. These storms can cause problems if adequate BMPs have not been installed on site. That's a brief overview of the intro to this volume and soil erosion. We're going to go into sedimentation, some of the BMPs that can be used in future videos. We have a free gift for you. It's a free WWHM 2012 course. You can access in that in the description down below to learn more about that one. And we will see you guys in the next video.